The question says that a non-uniform bar of weight W is suspended at rest by two strings of negligible weight as shown in figure 6.33. The angles made by the string with the verticals are 36.9 degrees and 53.1 degree respectively. The bar is 2 meter long. Calculate the distance d of the center of gravity of bar from its left end. So the question is saying that this is the given bar, which is non-uniform in terms of weight. That means its weight is not uniform, that is the density is not uniform. So we have to find out where is the center of mass of this bar located from the left end of the bar. Now this bar is suspended from two strings that are weightless. It means we don't need to consider the weight of the string in this question, string 1 and string 2. And it is assumed that the center of gravity is lying at a distance of d from the left end, and it is denoted by, the weight is denoted by W. So from the concept of center of mass, we know that center of mass is a location where the entire weight of a body is assumed to be acting. So it is assumed that at a distance d from the left end, weight is acting on the bar. So this is a question in which we have to consider equilibrium. Now equilibrium of a body in a plane can be established by finding the equilibrium of the forces in both the directions. That is, if our coordinate is having an x axis and y axis, then the force must balance in x direction and the y direction, and moment at any point from any point should be equal to 0. So considering the equilibrium in x direction, at first let us try to find the component of these two forces, that is tension in string 1 and tension in string 2. So the horizontal component and the vertical component are written over here, that is a t in t sine 36.9 degree in the horizontal side and t1 cos 36.9 degree in the vertical side for the string t1, and similarly for t2. Now in the x direction, we have got the horizontal component of both the tensions. So for horizontal equilibrium, these two forces should be equal. Now equating these two forces, we will get this relation, and this sine 36.9 degree has a value of 0.6. That's why it is written over here. Now similarly in the y direction, the weight is acting and the vertical component of two tension forces are acting. So by equating that, we will get this equation, t1 0.8 plus t2 0.6, that will be equal to the weight of the non-uniform body. Now using these two relations, we will get the relation in W, that is the in terms of weight of the body. So moving on, let us try to establish the equilibrium by making the moment 0 from the left end. So we are taking a moment about this left end point, that is O. So here weight W is trying to rotate the bar in clockwise direction, so we have given minus sign over here, and this T2 0.6 times 2. Now this vertical component of the tension T2 force is trying to rotate this bar in anti-clockwise direction, that is why it has got plus sign, and it is acting over 2 meters, so we have got 2 meter over here. Now this vertical component is T2 cos 53.1 degree, so its value is 0.6. Now moment of force is simply the magnitude of force times the distance. So the magnitude of force here is T2 0.6 and the distance is 2. So we have got the moment of force about this point of this force. Now this moment should also be equal to 0. So using the equation number 3 using relations 3, we will get the equation like this: W times D equals to 0.6 times W times 0.6 times 2. Now D will be equal to 0.72 meter. Now D is the distance from the left end of the center of mass W. So the center of mass of this non-uniform bar is going to be at a distance of 72 centimeters from the left end. Thank you.